No, noise.
No.
How about sampling?
We do it after this because
What
this
a-
one is very similar to Fourier transform.
What about the lab?
A lot of easy stuff.
Because tomorrow we get a lot.
لا
You got past year left.
عندكم نبات انتم ناخذ حق صالح.
لا كلها حق صالح حق مدري مين حق مدري مين حق مدري مين كلها نفس الطريقة ونفس الإجابات نفس الكود ما يختلف مرة ايزي قعدت تطل السراج عنده رسل لنا حق يعني حق
أسس السراج.
شخصين واحد صيني وواحد مدري ايش وكلها نفس الشيء
نبي بس اثنين.
Ready?
Ready.
أربع لعبات
This way.
عزيز
So we start.
No, just Aziz. خلاص we are four just.
Right, so the topic is Fourier transform, then we have
Sampling.
sampling, then we have a discrete LTI,
لا 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 لا
then
والله
there
والله
will
كل
be
شيء عضلاتي كلها مسجونة.
noise.
Noise.
But because of noise and Fourier transform, they are close
Similar.
A little
together.
bit.
Yeah.
Yeah,
similar.
so we do this first, and then we're gonna do this later.
بتوش.
Similar. Similar.
Right, so when we talk about noise, it,
Noise. Everything is noise. Even the energy.
yeah, the thing that we don't want.
Except Yuli. You're not noise. زعل صح؟
Right, noise is something that we don't want to. That is random signal.
Mm-hmm.
So let's say if you got a this is you have two signal, one to record, and with the noise it's becoming like this. So it's not good, right? So we want to minimize the number or the amount of noise in that. But to measure how much noise in the signal, we use a quantity called signal to noise ratio, or simply S over N, signal to noise ratio.
This
will
one
be
narration.
signal
noise.
to noise ratio.
Russia.
Ratio
اي هذا
will be equal to
تفضل عزيز.
the amplitude of the signal, FRMS of the signal, divided by the amplitude RMS of the noise. So this one belongs to signal, this one belongs to the noise. Yeah. So let's say we have FRMS equal to 1 and noise is 0.001 volt. You got 1000 signal to noise ratio. So obviously this one smaller, the better, right? Because we want to minimize noise. So we want as high signal to noise ratio, the better.
Mm-hmm.
And usually we will measure them in terms of decibel.
This is
Decibel? How to convert
dB.
it to decibel?
20 log.
20 log
10.
FRMS over 9 RMS. So this is how we measure signal to noise ratio in decibel. Right, so let's say if you have a the signal is 1 volt and the signal to noise ratio decibel is 20 decibel.
Mm-hmm.
How much the noise in that? I need to do the math here, right? You have 20
Loud.
signal to noise. Or signal is F
F.
over
to-
noise.
But we don't know the noise.
Yeah, you need to calculate the noise.
Yeah.
Equal to 20.
20, yeah.
So 20, log this equal to 1. So F over noise RMS equal to 10. So you have, if the signal is 1, so the noise will be equal to 0.1.
Yeah,
Yeah?
0.
Something like
But
that.
what, from where we get 20? Another 20. How?
Definitions.
Yeah, 20 dB, but we put it there, 20 log.
Yeah,
Why we take
This is
the...
how we calculate. This is what you get.
Mm.
Your given signal to noise ratio is 20. So we
Mhm.
use this formula, give you 20.
Good.
Alright, so reduce the noise to increase signal to noise ratio. Right. So you have the noise like that. So obviously we want to get rid of these things to give you back that thing. But the problem is because this is a random.
This one.
Yeah, because that is random. So there will be required some techniques in there. There are two methods to reduce the noise. Okay. First one is called signal averaging,
Low filter, high filter, doesn't.
and the other one is called time averaging.
Time average.
Right?
All right.
Let's talk about the first one. Signal averaging. It's something like you measure multiple times and then do the average. Like I want to measure the weight of this thing. So I first measurement I weighed about 110 gram. The second one maybe 105 gram. Third one maybe 112 gram. Fourth one probably 108 gram. Right? Obviously,
So-
different will be.
So
different
we take
value.
the average of this.
Yeah.
one.
Take average of this, and you got a true, well, close to the original weights of these things. So that's called signal averaging. Like you measure something, record something, you measure multiple times, and then averaging. This one called signal averaging. Similar. Similar, for example, that signal, we know the signal will produce something like that. But because of the noise, produce something like that. So we will measure that signal multiple times. So first time I will do this, second time I will get something like that, third time I get something like that. Right?
Until we.
Add them, let's say
No,
three together.
not acceleration.
Then divide by 3. Then you got closely look like that, and you would averaging the noise. Right? Make sense?
Next.
Yes.
This is for signal averaging. And the set of the signal here, we call them ensemble.
Ensemble.
Yeah?
Oh.
It's the set of the signal where we take measurement. Right? The large number of identical noise producing, and then they got output producing a large set of representative signal. So that's called example. Or a set of signal that we want to average. And the number average, let's say 3 in here, we call them sweep.
Speed.
We what do?
Speed.
Sweep, which is number of n.
3.
How many
Uh-huh.
times it's called
Uh-huh.
sweeps. Right?
Relate
But
divided by.
how much of the noise will be reduced if we're using signal averaging? So there is a formula of this, and you have to remember. Let's say the noise RMS is the amplitude of the noise after averaging, will be reduced by a factor of 1 over square root of n with the original noise RMS. Right? So let's say my original noise RMS is 0.1 volt, and I averaged 100 times. Okay, so the after averaging, I have the noise RMS will be equal to 1 over square root of 100 multiplied by 0.1. So it should be less by a factor of 10, which is square root of 100.
Yes.
So if you do 9 times, you would reduce the noise by 3 times. Yep.
Good.
So the more sweeps you have, the less noise you're gonna get. And obviously, with higher signal to noise ratio, because the noise is less, means the ratio is increased. Let's see how much the signal to noise ratio will be increased. So you have I have the signal to noise ratio indexable before, let's say, or original will be equal to 20 log
SN indexable.
FRMS over noise RMS. This one is original.
Mm-hmm.
After averaging, I have signal to noise ratio after, sorry, just say after, will be equal to 20 log F FRMS divided by the new noise RMS. Yes?
Mm-hmm.
The signal doesn't change, the weight doesn't change, right? Like my measurement, but
Yes.
the noise will be changed,
Yes.
Yeah.
right? And if I substitute this in there, I got 20 log of FRMS over 1 over square root of n of noise RMS before. Yep, I can take this outside. Sign here equal to 20 log 1 over square root of n. 1 over square root can be put on top as well.
Yes.
And plus 20 log FRMS over noise RMS. Yeah? This one is n to the power of 1 over 2. 1 over 2 can come in front. With you. 10 log n plus 20 log FRMS over noise RMS. What is? This one is a signal to noise ratio.
Original.
Original.
Yes.
So in another word, we can say the signal to noise ratio after will be equal to 10 log n
Plus
plus signal
The-
to noise
the
ratio.
original one.
Original. This
Yes.
one is a formula you need to remember when we're doing signal to noise, signal averages. Easy, right? So the difference will be these terms. If you want an increment of, let's say if you want an increment of 20 decibel, so you want increase of 20 decibel, that will be these terms. Just solve 10 log n equal to 20.
And the swab, yeah?
And it's the number of sweep or number of signals that you need to average. So you got n will be equal to, cancel this gives you 2, 10 power 2 you get 100. So if you want a increment of 20 decibel, you need 100 sweeps. Yeah? Or 100 times the signal. Make sense?
Makes sense.
What?
لا يا أخي
I hope we will understand it. Can we understand it with example or is this example?
This
هذه
is
كيف
number.
تجيب القانون ده وتطبق هنا.
Okay.
اتفاق في
والله ماني فاهم. يلا روح.
Alright?
Alright.
Right. So either example will be very straightforward. I want, let's say I have my signal to noise ratio original is 30 decibel. I need to improve the signal to noise ratio after is 60 decibel. So how many sweep do I need here? So you just need to put into these equations here.
Yes.
So you got 60 equal 10 log n plus
30. Yes.
So you can solve for this.
Eh,
Yeah, straightforward.
yes.
So you got 10 log n equal to 60 minus 30. So you got 10 log n equal to 30. And n is equal to 1000.
Yeah.
Right? You need to do it 1000 times 2 make this. Or even we don't need to know what is the original one, we don't need to know what is after, we just need the difference. Right? This one will be a difference between before and after. All good?
All good.
All good?
How did you get the end from here?
This one.
Yes.
You're not so comfortable with the lock.
Yes.
So, subtract 30, right?
Yes.
30 equal 10 log n,
Yes.
right? Divide 10,
3
3. 1 log. Log. Okay.
so 3 here will become the on top. This
Yes.
always 10 to the power of 3.
So it will be 300,
No,
1,000.
1,000.
1000. 10 أس 3.
1000 بألف ايوه 10 أس 3 yeah you're right
We got it.
Okay. Right.
حبيبي
This one
هذه
is
نفس المسوي
simple.
هنا.
The question of this will be very straightforward, simple. So you can see what is the advantage and disadvantage of the signal average. What the disadvantage first?
disadvantage
Yeah.
Of single.
What it costs to do the signal averaging?
the disadvantage you have to like you have to
Disadvantage.
take the what's it called ensembles
Ensemble.
ensemble many times or
Yeah.
the n many times
Right. If you want a more accurate result, you need to
Yeah.
do multiple times.
like 1,000
Yeah. You
Oh.
need to do 100 times, 1,000 times, maybe
yeah no.
million times to get a very accurate, reliable result. And you need somewhere to store that 1,000 of the result as well, right?
yes
Need storage. Alright, need a big hard drive, need a big something to put things into, need a big paper.
but
right, to
the
run
advantage you get very good result
result. Yeah, advantage you got a good result and
without noise
it doesn't affect the original signal.
yeah
Original stay the same. Okay? The weight of this one, the way you measure it doesn't change, right?
It doesn't change.
You just average and you reduce the noise without affecting the original signal.
yes
You got two things there, advantage, disadvantage.
على قلبك
Now let's talk about
لا
this.
تلمسني الله يرحم والديك.
Time averaging. Time averaging is have another names here. It's called moving
حق ايش؟
window average.
لسه عدوبة بدأ فيها ما أعرفها
Heard about this before?
moving window average
Yeah. Heard
moving
about that before?
yes
No? Alright.
yeah
Time
like
averaging
shifting
only require one measurement. Okay? It's only required one measurement. I measure the signal like this. And then I will select some sample in the interval called a window. So I will select the window here.
and move it
Everything's here will be add together, divide by the number of sample to get 1 point. Then I move the window by 1. So that my window will become here. Yeah, so I will select all the points from here to here, add them together, divide by the total point, get another point here.
Okay.
Keep moving that window along that signal. So you got
Until
this.
we.
Yeah, so you got that signal is out there. So that's why it's called moving window average. Right? It
yes.
will reduce the noise. There is examples in there. The action note. This one. Right, have a look at this. The original signal look like this, right? And because of the noise, it will become this. So obviously they want to
Okay.
reduce that noise. So they will select a window. This is the window. Alright?
That one?
Yeah, this one is a window.
Okay.
Everything inside the window have to be add together, divide by total of points in there to give you 1 point.
Mhm.
And they keep moving that window along. So what happens if you move that window? You will see this, 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 this.
Yeah, let's not.
That's noise. Yeah?
Very good, yeah.
Yeah? This one obviously has less noise than the
yes
red one. So
yeah.
if you keep moving again,
Again.
you will reduce the noise. So you can see the big advantage here.
Big
Bigger
advantage.
Yeah.
Let's. First
you
we-
have
let's
to
switch.
do a sample just one time
Yes.
the first
Record
one
one time,
record one time
and you can do straight away moving window average.
with the window
What is the disadvantage?
you have to get like more points it will take time
Not quite.
what the
The side chain.
Have a look at the red one here. We
Yeah,
want a
it's a
straight line.
change.
Yeah.
Now it's
It's a
becoming
change.
like this.
Yeah.
Uh-huh.
It will change the signal because it will average the signal as well. Yeah, the original has been averaged as well. Right? Well, not only the noise, but everything inside the window, including the signal, will be averaged as well.
Uh-huh.
So it will make the signal
change.
change.
A
Or we
little
call
bit.
them distortions. Right?
Retortion.
So there's another term for it. It's say create bias error, which is the difference between the original and after averaging the signal. So after averaging signal, always less than the original signal because you average them. This peak is always less than that peak because it's averaging at this point and that point. Always less.
Mm-hmm.
Yeah, makes sense?
Makes sense.
So it's have advantage fast, one measurement, disadvantage a bias error. So how to minimize the bias error while maintaining the noise performance here, which is reduce the noise here. So you need to choose a right side of the window. If the window is too big, right? If you select too much things there, the noise will be average good. So reduce more noise. But because if you average too much, you include the
It's
signal
always
in there as
signal.
well. So you got more bias
Bias.
error. Alright? If the window is too small, there will be another way around.
Reduce noise, move more.
Reduce less noise
Less noise, less bass error.
and less
Bass.
bias error.
Bias.
We want both. We want to have to reduce more noise and we want to minimize the errors. So there will be somewhere between this. Not too big, not too small.
Which one is good? It's the
Medium one.
single
Middle.
averaging or time averaging?
All depends on what equipment you have. If you can do signal averaging, let's do signal averaging. But if you can't,
That's-
you have to do time averaging. Alright, so in the time averaging, we need to choose the window, which is the big of the rectangle over there, as optimum. which is
Yeah.
somewhere between big and small. So we call them T, which is a window size. And it depends on how much noise that you need to. Right, let's do some math.
Sun.
No.
Now, in order to find the window sign, you need to characterize the noise first. So in the signal averaging, we don't need to know what is characterized, what is characterizations or what behavior of the noise, right? We just everything. But see here, in order to do time average efficiency, you need to know what is a characterized
50.
of the noise.
The noise.
Yeah. So one characterized of them. First one is RNN. It's called auto correlations functions. Okay. And another one is SNN. It's called power spectral density. This one is the time domain of the noise. This one is frequency domain of the noise. Obviously, you can say Fourier transform of this autocorrelation.
SNN.
SNN
Omega.
omega.
This one, Lee. This one for time
Time averaging. is only.
time averaging. Okay.
In signal averaging, we don't need to do these things.
Uh-huh.
And we just do script and calculate and that's it.
Good.
But in order to find T, window size in here, we need to do all this.
Uh-huh.
Fourier transform. This
Yeah.
one is what we already have done before. yeah?
Yes.
Yeah.
So in the question, might give you one of this. Might give you this, ask you this. Might give you this, ask you this.
Easy.
Two way. Right.
Do you
Yeah.
remember the formula?
Yep.
Good.
So this one is our formula that you need. First one. The
Yes.
second one, the noise RMS can be calculated from autocorrelation functions by substitute RNN with 0 and take the square root.
Mm-hmm.
If you have this function, substitute 0, wherever you got tau in there,
Mm-hmm.
We
and you
got
no
NRMS.
Yes. The third one you have is equivalent bandwidth.
Lee, for the first one, Fourier transform, should we use the first topic
Yeah.
to get it? Yeah,
Yes.
almost all of them,
Yes.
duality and sync.
Yeah.
Okay.
You may use one or two of them.
احنا خدنا فورير ترانسفورم وفورير سيريز
Fourier transform, Fourier series. خدنا كلها.
Alright.
أول topic.
The next one is equivalent
هي
bandwidth.
خدنا الاثنين يا أخوي.
Equivalent bandwidth can be calculated from this power spectral density. Looking at the integrations of SNN omega divided by SNN
Fourier transform.
0 d omega. Alright, what is equivalent bandwidth? I'll tell you here. Suppose that you have a limited power spectral density. This is frequency spectrum, right?
Uh-huh.
You have the noise looking like that, right? So we can calculate this area, right? Because it's a limited
Yeah.
area. So if you can calculate this area, we can represent them, okay, in terms of a
Bandwidth.
rectangular, where the area of this rectangular will be equal to the original area of your original signal of the noise.
Mm-hmm.
And this much is called equivalent bandwidth, right? Equivalent area compared to the original
Yes, yes, yes.
power, right? This is how much power that you got original. I will represent that in terms of
Rectangular.
easier
Okay.
to calculate.
Yes.
Some called equivalent bandwidth. Right?
All right.
So this is how we can calculate that much over there. And the other side will be symmetrical.
Yeah.
The fourth formula. After calculating this, we can calculate a correlation term, tau c. Will be equal to pi over equivalent bandwidth.
Uh-huh.
Okay. It's called correlation term. This one should be measured in radians. So you got some pi's in there. This one, pi, radian, and radian cancel with you term.
Time.
Second.
Second.
And the fifth one will be the relationship between the original and after averaging of the noise. So we got noise RMS after will be equal to square root of tau c over t multiplied by noise RMS before. So this one is after.
What's called after?
And this one is
Before.
So noise RMS after will be reduced by this much. Right. Still remember what the formula of the signal average should look like?
Signal averaging?
This is time average.
Yeah.
This is signal average.
Yes. NRMS or
Okay.
N
RMS after
equal 10.
No, something like this. Something multiplied by NRMS.
Yes.
What things significant?
S over N.
No.
What's called
A factor.
factor?
After averaging, it's reduced by a factor of
Log. 20 log. لا لا لا.
how much noise would we reduce if we do 100 times?
100 times.
Yeah.
10.
F over N RMS.
No, come on, we do 100 sweeps. How
Yes,
much we
yeah.
gonna reduce? How many times?
100. No.
10 times.
10 times. I told you 10
Square
log.
root of 100.
Yes.
Yeah.
10 log.
No. It's a simple.
اوه الاخيره
يا اخي لا تلمسني الله يلعن شكل الشيطان.
اوكي.
Alright? If you do 100 times, 1 over square root 100 would be 10. 1 over 10.
10. Yes.
Looks
والله علم مو طبيعي.
similar
بسم
each
الله
other?
والجسم.
So this quantity in signal averaging will be similar to this quantity in time averaging. So you can say, well, if you flip it over, you can say T over tau c on this side
Mm-hmm.
will be equivalent to N over this side. Equivalent, right? So if you do 100 times in there, this over this will be equal to 100. So if we have the signal to noise ratio after equal to 10 log n plus signal to noise ratio original. We can do the similar things in here.
Yes.
Signal to noise ratio after
Yeah. Equal
equal 10 log
log n log TC over
T over 2C
T over TC
signal to noise
origin.
Plus this one.
No. Not plus. خلاص
This
هذه
one time average, the other one is signal average. Yes?
بس هو ساوى T over TC بالN وهنا غير القانون خلاها بدل N خلاها T over TC ولا هو نفسه يعني. Okay.
Okay.
Clear.
So similar to this one. This one will be a difference. Let's say I have currently 30 decibel, 30 decibel, and I want it has to be 50.
50.
So
Okay.
this one has to be 20 decibel.
Yes.
Similar to this one. If I originally have 30, I want is 50, so this one will
20.
be 20. So you just need to solve 10 log T over tau c equal to 20. This one will give you a difference, right, between before and after averaging. So in order to find T, you need to find tau c. Tau c comes from here.
Mhm.
And you
Find
need to
out
find
the-
equivalent with
I have
equivalent will come from here.
Oh. Wow.
That's why we use this one.
Yeah, that's why we're gonna use this to do that. That's
Cool.
how
This one is easy.
Yeah.
That one?
But this one always come in the exams. And they will not be in the formula sheet, so you need to
Really?
remember all this. 1, 2, 3, 4, 5, 6,
7, 8.
7, 8. Alright? Just 8 formula. But they are similar, so it should be easy for you.
Still similar than the old things, duality and those stuff.
Yeah. And you're gonna use those properties to do this. For the transform.
Yeah.
هذا الحين forgot the signal average والtime average.
ليه? What properties we always use with this one?
Always.
Always what properties?
I'll give you an example in the past exam you will see. Last year.
هذه ما بدك تغمضها.
طفي اللمبات.
ما أعرف.
لا بس هذه ما تبان واضح بعدين.
لا النهار في نهار
خلاص خلينا.
أجل.
لا هو مو لا اسمع
تفتح
هذا بس عارف ايه انا اصور فيديو
Alright? This is question 4.
بس عشان يعرف فين السؤال بس ما راح اقرا السؤال من الفيديو.
2013.
اي اقوم افتح الاختبار واقرا. 2013.
Question 4.
Yep.
Question 4.
Question 4 probably has 3 parts. The first part is the one is theory of noise. So I will give you that before exams.
هذا بيتر كدوش بارت يا؟
Yes, those parts.
كيف يقولون
Oh, but the easy things. How is the spectrum
لا مو كله.
power
نصه.
spectral density relate to
شوف قلت
autocorrelation function? This one you can write this. Okay. It
For-
will be related by the Fourier
First
transform.
one. For this one we can write this one, yeah?
What is the relationship between this and this? Well, it's a Fourier transform relationship.
Fourier transform. Okay.
Yeah, this one is theory power. How is the root mean square ambit of zero mean stationary relate to autocorrelations function with the knowledge, which is this one. Okay, you can write this formula.
That's all?
This is the non-RMS amplitude. This one is autocorrelation.
This is the answer.
The first one
ليه?
and
This
third
is
one.
the answer?
I will give you later.
يقول له theory يقول لك يجيب لك. This is the answer, yeah?
Yeah.
والله. Yeah,
So,
okay.
because this formula is not given to you, so it asks you to write it again. Like, what is the duality theorem of Fourier transform?
Ah.
Right? If not given, then we ask you. Like this, like this. Right.
Okay,
Let's
right.
do this part.
This is the calculation.
Yep, this is calculations.
إلى الآن ثيري. ما كله ثيري ده الأسئلة. الأربع أسئلة ثيري.
الأربع أسئلة دي كلها طلعت تيري.
don't have to write list of formulas in here. That's one. Signal averaging. We have no RMS
بالضبط.
after
بالعكس
and no
طب ليه ما
RMS.
قال لي زي
And signal to noise ratio
بس كذا
after
يعني
10 log
هذا الشباب كلهم
plus
يعرفون
signal
رقم
to
سريع.
noise ratio.
شو المشكلة طيب؟ مرة يا
رقم البنك حتى الله يستر.
شوف هذا.
الرقم السري حقها
Time averaging.
طيب.
And RMS after.
طيب وش
ما
تسوي؟
في له شيء
وش تسوي له؟
وهذا بدون والله
طيب وش
تفك على
تسوي
قلبك
له؟
ليش خذ راحتك
RMS
الرقم السري حق البنك 5 0
after 10 log.
3 7 والله العظيم خذ.
اعطيني البطاقة يقول لي ابدا.
بعد الراتب بكم يوم اعطيك اياه
ما لا قاعد تسوي كذا.
شكله حشيلة
زي كذا.
شوف
قسم
كيف، صح.
بالله، قسم بالله تصير زي كذا. تلحق الوالد.
من الوالد؟
ابوك.
ابوي ما عندك شيء
عندك أشياء.
بس عادية على كبر سن
على كبر سن يعني بتلحق انت يعني. اقعد تمكنها كذا بس.
يا اخي ما ادري
ها؟
كان هذيك كلها فاسدين كذا يعني بشكل عام.
This is all thing that you need in noise.
هذه مصيبه.
هذه
Right? All 8 formula. Yep, everything's will be there.
Yeah.
كول
Good.
We're gonna use everything's in there. Alright. Let's do these questions.
اوكي
It's in here, it's already given you a S, right, which is power spectral density. It's already
Yes,
given
got
some
it.
of that. And asked you the autocorrelation function, which is
autocorrelation function ده
autocorrelation, which is
RNN
RNN. Yes?
yeah easy
The first one is RNN gives you SNN, which is 10 minus 3 cube of 2 pi 10 power 4 ohmic. What is this?
duality
Huh?
ها
كيو لا
How to do this? How to find this? Yes.
UQ or QU or which properties do you mean ولا
No, no, no.
How can
This
we,
step.
okay
we do Fourier transform? Or?
Yeah.
okay Fourier transform
So what the first step?
choose the from the formula sheet yeah UQ I think Q we have to choose like that's one QT
So we start from QT.
yeah and then we do like dualities duality
Duality, how the duality goes in here.
okay it goes down for F yeah
Yeah.
T sin to power of 2 T small T big over T 2
Yeah. And how this become?
2 by
By
multiply Q T
Q T
T
minus T.
no no
Minus
no
omega.
it doesn't matter omega or minus omega yeah
Omega
It's an
minus.
even function. So
yeah even
Yeah.
mix
Right. So we try to make this look like that.
yeah
So obviously the things here have to be equal to this one.
okay T equal 2
2
by
باي
point
multiply
10
So we have 2 pi 10 power 3, which is this one. Sin square of 2 pi 10 power 3 t divided by 2. So I mean pi's in here.
yeah cool
Transform into
2 by
pi
Q
2 pi 10 power 3
omega excellent
Right?
and we have to 10
So minus 3 in front.
okay
And we can cancel the 2 pi and 2 pi over there.
and multiply with 10 minus 3 over
Yeah.
power of minus
So we
3
multiply 10 minus 3 both sides.
yeah so it will go this together
And it should be yeah. Yeah, it's same.
and
That one is good.
Yeah.
Yeah.
So this one is this one.
Yes.
So this one should be this one.
Yes.
and this should be
Cancel.
cancelled.
Yeah. It should.
So we got R and N will be ultimately equal to
Sine power of 2 pi 10 power of 2.
easy.
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 Duality.
So we can do the next one.
Next one.
المشكلة لما تجي تبغى تفكر انت كيف ايش اللي تحت.
ايوه هذه
هي
هي
المنطقية.
ايوه
لا ما
يبغى لها وقت.
والله يبغى لها تركيز يبغى لها
صادق.
يبغى لها حق.
لازم تفهم.
Now second one.
براكتس.
There are RMS
من ورا.
amplitude مدري amplitude
RMS equal.
سوي سؤال.
RMS يقول الله شوف يعني
Which one?
last one.
Last one.
Yeah.
So we're gonna substitute R and N 0, take the square root.
Square root.
So we're gonna put a 0 in there. Ah, this is tall, so better to make tall over there. Alright, so we substitute 0 in there.
Well, wait, tall.
That's tall. This is variable.
Just change the T to tall.
Yeah.
To tall. Okay.
Doesn't matter. Now, we put a 0 in here.
It
So
will
you
be
got
0.
6 squared 0.
Yeah.
How much is 6 and 0?
5 و 0 الله عليهم. But here we got.
No, can't do this. 6
Wow.
and 0 is 1.
It's like sign.
No, this is sin, it's not sine.
5 و 0. So the answer will be 1.
Sign zero.
Okay, sin 0, which is this one.
كوساين
It's 1.
الساين
Will be 1.
Uh-huh. It's 1.
طلع عندك سنك؟
ما في سنك.
How can you
How can I know
Definition.
this?
Definitions, you can't calculate this.
Definition.
doesn't bring any?
Is it
just
allowed in
sink.
the exam this one? This big?
You can TI 89 in them. But you can't calculate sin 0 with calculator, it's not defined. Okay? Programmable graphic calculator.
Yeah, it's allowed.
Yeah.
The big one allowed, yeah?
But you
Cool.
don't need to use that.
هذا ما تدري يقول لك على كل واحد يمر شط ريست شط ريست.
مو كلهم قالوا كذا ولا مدرس هوك ولا لا هوك ما
لا
نسى.
لا هو هذا السمستر السنة اللي فاتت مر على الشعب كله. هو نفسه
Alright,
مر على الشعب
next
كله.
one. Correlation term.
حق الويبز ايوه لكن هنا لا.
Correlation term. What is correlation terms in there?
قفلها وخليه يسوي ريسيت. correlation time يا حبيبي لي. ده correlation time نايس. Okay.
2000 كم هذا 2013
Which one? After and before. Origin, yeah?
No, correlation term. What is the definition of correlation terms?
Correlation time.
That's
So
right. That's it.
TC.
Yeah, this one is correlation term.
Yes.
Correlation term is pi over this. What is? What's the name of this one?
Bandwidth. We have to find the
equivalent
Band,
bandwidth.
equivalent band.
So we need to find this one first. S and then
Omega.
divided by S and then 0 d omega. So you need to substitute S in here. Equal to integration of 0 infinity 10 minus 3 q 2 pi 10 power 3 omega divided by 10 minus 3 q 0, right?
Yeah.
How much is the q 0?
Q0 will be 0. No, no.
How the q look like? What is? How many?
1.
1. So this one is equal to 1. So d omega, so this one will be cancelled.
Mhm.
That only gives you the integration of 0 to infinity
Q2 by
q2 pi 10 power 3
Omega.
omega d omega. Okay, how
See
can we
that.
take these integrations?
ما شاء الله عليه.
Right? So if
Alright.
you represent it using a graph, the integration is actually the area from 0 to infinity of this diagram. This is 1 and this one is 2 pi 10 power 3, right?
Yeah.
This is part is 0 and we need to calculate this area. The which is equal to that integration, right? How to calculate this area? Easy.
With bandwidth. Okay.
Area. How to calculate the area of this triangular?
This like energy transfer, Fourier transfer.
No, how to calculate the area of this one? A, B, and C.
Pythagoras.
Pythagoras. What's called
what
the
type
rules
of-
for Pythagoras.
Area, no, area.
Area.
How to calculate area of this one?
Tan.
Take
Square.
this, times this,
Yes.
Yes.
divide by 2.
Divided by 2, yes.
How can we use it then?
Take 2 by multiply.
1
Take this, times this,
Yeah.
divided by
divide
2.
by 2.
It
Yes.
will be 2 by multiply 10 of 3.
Yeah, so we have this one equal to 2 pi
Yeah,
times
same,
10 power
same,
3
same.
times 1 divided by 2.
Yes.
صح.
صح. Excellent.
Yes.
That's it. This one is area.
نسجل صح عشان نكتب النص ده كمان.
Yep. So we can calculate equivalent values. Then we can calculate
هذه ضربة
توصيل.
تقسم على 2.
ايوه.
pi over this
Yeah, bit
equal
of
to pi 10 to the power 3, 10 to minus 3
Yeah.
second. Right, straightforward.
Straight.
And 4-1. The duration of moving window average required to reduce the noise power by 20 decibel.
This one should be before and after. S over N.
Yeah, إذا درست.
Yep. So we need to reduce it by 20 decibel. Mean we have to take this as the difference. So the difference will be 20 decibel.
Decibel.
So we can write this formula. Oh, we can obviously take this one. 10 log T
T
over
over
tau
tau.
C equal to 20.
Okay.
Okay.
So we can solve for this now. Cancel this and this give you 2.
2. It will be 100.
Yeah. So I got T over tau C equal to 10 power 2. 100. We know tau C, so we can find T.
T.
Yeah.
100 times tau C. Tau C is 10 to
10
minus
after.
Equal 0.1. Isn't it?
3.
Yeah. Second.
That's it. It's easy questions.
Really?
Allah easy.
They look long, but doesn't look much.
Allah easy. Cool.
Okay.
Okay.
It's only 10 marks.
Describe
Now this one is another topic.
another topic.
Yeah. Okay. Let's try another one. Another 12.
والله عنده من 1 إلى 30.
هي كلها موجودة عندنا.
أنت لقيت عندك محلول أعطاك؟
أنا محلول.
Well, actually, the
طبعاً
even
بعض
series
الحلول
is
هي.
quite similar.
الأربعة
Odd
اللي
years
نستخدم
quite similar to
بس
each other.
13 بس 12 ويجي نفس مثلا.
إيه
لا كلها موجودة مخزنة عندنا.
اي حلو اذا استنى قسمه عندي.
خليه يسحبها من الكمبيوتر وما فلاش عندي.
Alright, this is question
أنا
4,
ما هلا.
2012. And if you have looked this in 2010, that will be similar.
واو.
2010.
Yeah.
إيه.
10 and 12 are quite similar.
So it would be similar like 11 now.
معناته 3000 احنا.
Not quite.
لا.
11.
12.
And 11 and 13 will be similar as well. See, if you have a look at 11, you will see
يعني ليش
see
تقول
this P
يعني ليش؟
and Q function. See the Q function here?
Yeah.
Yeah. It's asked you in 2013, right?
Yes.
Yes, easy.
So 11 and 13 is quite similar.
So 14
10 and
and
12
12
is
will be
quite
similar, صح?
I'm not sure.
So we'll be
يعني
12
كل
and
زوجي مع
10.
بعض يعني كل
Let's do 12 and 10.
Good.
Okay.
Leave 11 and you can leave 11 easy. Because 11 and 13 is look like this. Exactly. They just change number.
Aha.
So you can do 11 for yourself.
مستحيل يجينا.
Let's do the 12. So you can
2012.
Part A is theory part. I'll give you later. Let's do part B.
So
Just have a look at this.
2012, yeah?
A. Part B. Question 4?
Yes.
Question 4.
ب8
قال بعدين.
شوف بالله لا تلمسني يا خالد تكفى.
تقول لي المسني انا ما المسك.
Okay, have a look at this.
لا.
اوكي.
So you have n repeated experiment. So you got number of sweeps. It's n.
Yes.
Signal to noise ratio is 20 decibel. So you got original, signal to noise ratio, right? Signal to noise ratio, original, it's already given 20 decibel. The equivalent bandwidth is already given, but this thing is not in radian, in hertz.
So we have to change. Yeah.
Yes, equivalent bandwidth. Sorry. Yes. How to convert them into radian?
Radian.
Yeah. Radian per second.
20.
لا
180.
No.
No.
300 hertz. This is F, right?
Yes.
You have to convert into omega.
Omega. 1 over T. لا لا.
Omega equal to
Omega equal
2
or
2 pi F.
2 by F. Yes.
Yeah.
Yeah.
2 pi multiplied by 300 radian per second. Okay. How many sweep need to average in order to increase the signal ratio to 50 decibel? First one.
bandwidth equals to bandwidth. Yeah.
How many sweeps to give the signal to noise ratio 50 decibel? Easy.
How many sweep? We need N
Yeah.
after.
So we have signal to noise ratio after equal to 10 log n plus signal to noise ratio
Before.
original.
Original. Okay.
So they need this one is 50.
Mm-hmm.
This one is already 20. So this thing will be
How we get 50? Ah. Okay.
so we have 10 log n equal to
30.
and 10 we give 3 here
Yeah.
and 10 power 3.
10 power 3.
1,000.
1,000.
Yeah, 1000.
Yeah.
Got it.
انا أقول
لا سهلة.
10 30 ايش سوى؟
طيب انا اقول لك دحين نبغى احنا ال 10 لوج ان. فاهم كلام؟ نبغى ال n. طيب ايش المكان اللي هنا لو سويت له فيه ال 10 لوج يعطينا 50 زائد 20 يعطينا 50. فاهم؟
20 زائد
ها؟
20 زائد 5.
فهمت؟ 20 زائد ايش اللي هنا يساوي 50 30. صح ولا لا؟ اوكي. نزل اللي هي 10 لوج ان بكم؟ 30 صح؟
غير العشرة
10 لوج ان ب 30.
تمام معك.
ايه تنزل تحت سواء ب 30. طيب يبغى الان لحالها، ال 10 لوج بيشيلها. يقوم ايش يسوي؟ يحط الباور بس، يحط الرقم يحط الباور حقه. خلاص تطلع لك 1000 1000. اوكي.
A second one, simple.
مرة سهلة.
Second one.
Have a look.
What kind of moving window is required to increase the signal? This is the length.
Yeah, window.
The window, yeah.
Which is
Second one.
No, let's look.
Yeah.
Yes.
so you have do the same thing here. Signal to noise ratio after
Well, this question is easier than that one.
10 log T over tau C plus signal to noise ratio original. Yeah. So
Really?
again you have 50.
We use which one? Hmm?
Time averaging.
Yeah, which one?
Just mark as because
Yeah, good.
موجودة
Sorry.
اللي عليه خطوط سوداء.
So
Yeah.
again we got this, right?
Yes.
So you have 10
30.
log T over tau C have to equal to
30.
30.
So in order to
Here.
find T, we need to find tau C first.
Yes.
Yeah.
So how tau C you gonna calculate?
Pi over omega.
Bandwidth.
Bandwidth.
Tau C equal to pi over
Bandwidth.
omega.
Omega.
So pi over this one, which is pi 300. Pi cancel.
Keep
Which
on
is
the
1 over 600.
Yes. صح.
Yeah.
So you have T equal to
No, not T.
T over 4C equal to 1000. Just look like this.
Yes.
Then you can say
T equal
1000
TC multiply with
4C.
TC. Yeah. Which is 1000 multiplied by 600.
This will be 1,600.
6 second.
Lee, how you get on it will be bandwidth
Yeah.
600.
Yeah.
I cancel. 2
Cancel.
times 300 is
Yeah, 6.
He give us already 300.
yeah.
هو اعطانا ايه بالهرتز وانت اللي قلت الجواب ايه حولناه راديان بار سكند.
Yeah, I thought we could do the same as we go to the.
No, this one easier.
Cool.
Yeah, it's easier.
This is coming in the test, in the exam.
Explain briefly why we import noise and bias.
Okay.
I explain. Yeah.
Yes.
Right, so based on these calculations,
Yes.
we have 1.6 second is the window length. And if you put the 1.6 second, we should get 50 decibel. But in this calculation, we ignore the bias error.
Mm-hmm.
It says so, no bias in the second
Yeah.
part. But if we include the bias, we not get 50 decibel. Why?
Because the signal will be
Signal will be
move.
Let-
after is equal to, let's say 20 log FRMS over noise RMS after, right?
Yes.
So we assume this one doesn't change.
Yes.
So we got 50 decibel.
Yes.
But because of this one changed, so FRMS
Now with bias, this
after
one is changed.
will be less than the original FRMS as well.
Yes.
Sure.
Because of the bias. So if this one is less, means this thing will be less than 50
Less.
decibel. So signal to noise ratio after will be less than 50 decibel if you include the bias because this one is less. Okay?
Just wrote this one.
Yeah, that's it.
Here are three. We should go to
Lines.
3 lines.
Yes.
1, 2.
And we wrote 3 short lines.
Doesn't change.
No bias.
Yeah.
Okay.
So you got 50, but if you include the bias,
Bias.
this thing will be less.
Yeah. Sure.
So you got less.
Good.
Yeah.
Well, I like this
Okay.
question.
Easy, right? And third.
Easier than 2013.
Yeah. But in 2010 it's something more tricky. It's 2010. Again, also we
2000
have two parts. One part,
2010.
what is an example, what is
Question
the
Question 4.
question for part B.
This one RT, there's no Q. So we have to find the amplitude of the noise. This is much cheaper. ها يشبك انت نايم ولا كيف؟ والله حلو الترسيم.
Ready?
Ready?
So what already given here? R and N
RT
is
4 multiply
10 minus 4,
6
6.
No, no, yeah, minus 6, yeah.
EXP
Exponential
Exponential يا حبيبي.
minus 2 over
6
الإي هذا.
minus 4. Yep.
Yep. Yep.
First one. What is the RMS amplitude?
Find out RMS amplitude. RMS.
Noise RMS equal
1 over N or lower.
which one?
It's up with that. For
No, no, last one.
That's one.
Yeah. Square root of RNN, 0.
0. So we just need to substitute zeros in here.
Yeah.
E to the 0 is
0, which is 1.
1.
1.
And square root of this one only, right? Square root of 4 10 to minus 6. U 2 10 to minus 3. O.
Excellent.
Find the power spectral density of the noise.
Find the bars. This is the noise.
Which is a Fourier transform, right?
Fourier transform.
Or what is Fourier transform of this one?
We go
Ah.
back to
The absolute value of f omega squared.
No, just SNN, that's it. Power spectral density is SNN.
S.
and then
This one is called power spectral density. This one.
Okay. So
Alright, so you can go for the formula sheets and see
Yep.
which one.
which
See the obvious one there?
QT? Any? Okay.
You have RNN,
Eh,
Fourier transform with USNN. You need to find this. So you're already given this.
yeah, we already given which one? RNN, yeah?
Yeah.
This one. We don't.
UTE power of.
that one is signal.
Oh, which one look like whatever things in there? Which one? This one.
This one, okay. UT.
طيب ايش عليها؟ صورها يا خالد. صورها ليش عليها؟
ايش؟
عشان نعرف شيء. 4
Come on. How to find Fourier transform this one?
One.
Just a minute, بالله, just a minute.
هنا.
Second one, there, second one.
No. See the absolute values here?
It's
This one, 1/2T.
Yeah.
Absolute.
absolute value غير لك الوضع.
طلع منها غبرة ضربت.
Gives you 1 over 1 plus
1/1
Omega
plus
T.
omega T
square.
squared.
Right, so we just try to make this look like this, yeah?
Okay.
So you got 10 to minus 4 here.
تو ضفارك الطويل ده.
10
تبي
to
يخش
minus
بعينك.
4. So we have 1 over
2T.
زي شرير
10
الحمقاء.
to minus 4. E to the minus T over
10
10 to minus 4.
going to
We always use duality.
No, it's right, it's straightforward. There's no dualities in here.
Really?
Yeah, we don't need to bring minus 4. Just substitute. 1 plus omega 10 minus 4 square. What next? How to make this look like this? We bring this into the other side first.
Yeah.
So we got e to the minus t 10 minus 4 gives you 2 times 10 minus 4 over 1 plus omega 10 minus 4 square. Then we multiply
By 4
4
point.
10 minus 6
point.
both sides. So you have 4 times 10 minus 6 in here. So 4 10 minus 6 in there.
Got it.
Yeah? So you got this one will be equal to 2 times 4 is 8. This time this will be
Minus 2. Sorry, 10.
1
1 plus omega 10.
This one is called power spectral density or S. Oh good? No?
yeah, I'm good. Yeah,
All good, all good.
sure.
Alright. Let's continue. by the equivalent bandwidth of the noise.
Find the equivalent. Ohm.
Yeah. Erase this.
Yeah, yeah.
So keep this. So we have S and N equal to 10 of x with 10 minus 10 of 1 over 1 plus omega 10 minus 4
Yeah, yeah.
whole square.
Cool.
Now, how to find equivalent bandwidth? Ohms equal
Ohm equal
integrations of this one,
this one, yeah, SNN.
SNN over
1 over 1 plus
1 plus Z.
omega 10 minus 4 square
Yeah.
over the
8
S,
point
and you're gonna substitute 0
0 here, so it will be 1
1
over
over
1.
1.
We don't need to write it. Okay,
and this will cancel as well.
so it will be just 1 over
That
1 over 1 plus
square root of 1 over 1 plus omega multiplied 10.4.
square d omega. How to find these integrations? You cannot plot them.
Yeah.
Like the triangular. You need to use the trick with this formula sheet. This one. Dx over 1 plus x
Pi
square
over-
integration into pi over 2. So we will try to make that one look like this.
Okay.
Right? So how to make
Maybe
this
let's do
look like this. So obviously the x here should be omega times 10 to the minus 4.
Yes.
So I put x equal to omega times 10 to the minus 4.
Mm.
it's same. Same.
So you got dx will be equal to
1.
no, derivative for both sides.
Ah, yeah.
10 to the minus 4 d omega. Because I would convert
Yeah,
everything
yeah,
into
yeah.
the x, right? So d omega will be equal to dx over
10
10
minus 4.
because I will convert everything into the x. So this one will become integrations of, still there, 1 over 1 plus x squared
Yes.
multiplied d omega, which is
dx over 10 power of minus 4.
Here we go.
So
So this one,
just multiply it.
this one is already done in the formula sheet.
Excellent.
And we can bring this one outside. 1
Yes,
over 10
yes,
minus
yes.
4 will be 10 to the power 4. 10 to the power 4 multiplied by the integrations gives you
Pi over 2.
straightforward.
Allah, mashallah.
Uh-huh.
Good. Straight.
Math.
Math.
I know it's math, but I forget this math.
إلا صح.
هي صح انا عارف بس ابغى اذكرها يا اخي. اوكي.
Okay.
لا فهمت دحين الاكس خلى لك هو نفس الدبليو
Everything in there is will be in the formula sheet.
الديريفيتيف اوف اكس دي اكس 10 الاوميجا تروح خلاص. بعدين الديريفيتيف اوف اوميجا منها برضو بطلع لك اياه خلاص.
Everything will be in the formula sheet. If you not pick the one in the formula
قلبها
sheet, you will be wrong.
شوف قلبها شايف
Alright.
قلبها شفتها
So this one is
قلب
your
هذه
bandwidth.
شوف هذه قلبها شايف هذه سوى ديريفيتيف بالاكس من الاوميجا فاهم كلامي؟ اتلغت الاوميجا وخلاص سوى ديريفيتيف صح؟
حطها هذه ايوه.
هي بعدين قلبها قال لك دي اوميجا ايش تساوي؟ تساوي هذه قسمة هذه ايوه كم نزلها؟
All good?
حبيبي اوكي
Alright, so let's keep going.
نفس المسافة بيدنا
What window length of the rectangular moving window image
الله طاح
is
عليك.
required to reduce the amplitude to 20 microvolt?
This one which question?
4.
V. Yeah, how many?
What
Window length.
window length?
Window length. Uh-huh. That means T.
Yeah.
Okay.
So we're gonna use that one.
Right, so which formula?
The one on the
The one.
Moving window average, right?
Yes.
The Annoy RMS before and
Yes.
after. So that Annoy RMS after equal to square root of tau C over T Annoy RMS before.
Yes.
How much before that we already calculate?
Before which is
Before which is the part one.
part one. Find the RMS amplitude. Nice.
Yeah, how much do you remember? How much do we need?
30.
1.6. No.
The result of part one.
1,000. No.
لا مو هذه.
Come on. Part one. How much did we calculate?
2 by or
3. This is before.
yeah before.
And after they want
After
is
20.
20 micro. 6.
Uh-huh.
So we can calculate this. Yeah.
Yes.
So will be
Just a minute. Okay, wait.
So we have divide them.
Just a minute. الله يلعن 20 multiply 6.
وين؟
تعبان فيك شيء عزوز؟ تحتاج شيء؟
لا.
حبيبي ايش بشو؟ 1 multiply by 10 power of minus 8.
Right. Okay. 10 to 8. So you can square this thing. So you got tau C over T equal to square.
التي سي والتي فين جبت انت؟ لو 20 قسمت على هذه؟
هذاك 20 قسم التو بس هنا واحد ضرب ليه؟
Minus 4.
اوكي. So T
No, this is not correct.
المفروض كده يكون minus 7. نحطها minus 7.
No, this one's not right. This one is 10 minus 2 something.
كيف نسوي؟
Right? And then you
حطك
can
واس.
calculate T here equal to tau C divided by 10 minus 4. So tau C correlation term had to be calculated from the equivalent bandwidth, right? So you got correlation term equal to pi over equivalent bandwidth. So
Yeah.
pi divided by this one.
Hello.
This one is 10,000, 5,000 pi.
Pi over 2.
Yeah. 1 over 5,000.
Yeah.
Yeah. So you substitute in here.
TC.
Okay.
Hello. ايه هلا.
Yeah. Right. So this is how you calculate the window length. And we can do the similar thing with the sweeps. So the last one as well.
بس حط substitute 1 over 5000 في التي سي
ها؟
التاو سي
ايه؟
على 10 طلعت 2 سكند.
طيب هنا مطلع تي سي على ذا.
تي سي تاو سي.
طيب وليه هذا اللي نزله تحت؟
هذا كمل. قال لك الام اللي هي هذاك نتيجة،
ايه
والتي يساوي الباي على الام. بطلع الام اللي هو النتيجة دي 10 اس 4 باي على 2 طلعت 5000 باي.
ايه
باي على باي ويدش.
ايوه صح فهمت. اوكي كول كول.
Now, let's do the last one. How much?
How many square
How many squares? Right?
would be required to reduce
Well, we can use the same formula except for we just need to substitute this.
ان 20 log
1
n.
over
20 log n. ولا 1 over 1 over n yeah.
Or you can say t over tau c in the previous question will be equivalent to n in this question
Excellent.
because they achieve the same result.
Same result.
Yeah.
Yeah.
Now it should be equivalent, right? How much you got before?
tau over tc 10 over minus no ذاك الجدول.
يلا انت تطلع فلوسك وكذا ماشي المحاضرة. ركز ما تبغى لا تجي وخذ الفيديو.
10,000.
ركز.
10,000.
Yeah. Or you can solve it and you get 10,000. Right? So 10,000 ton. So you need to do this window, sorry, signal averages.
عزيز يسولف.
عزيز
Easy?
تسولف؟
يقول شو بالشاحن.
الشبكة هناك.
ايه قسم 2 على 1 قسم.
اللي هو طلع 2 seconds
قسمه
على 2 1 over
1 over TC.
1000. إيه.
Right? So we have done 13, 12, and 10. So left is just 11. You can have a look at this one. It's all a Q again, very similar to 2013. And if you keep going back, it will be harder.
Harder?
Yeah. Harder in 2008 and
9.
9.
What do you think?
وقد ايه الدين قال مو ده.
Right. Sync function, so you need to do duality here. In 2009, it's not too hard, but it's harder than the 2012 and 13. And,
This one harder than 2013?
ايوه يقول لك هذه اصعب لان فيها سينك ودواليتي فيها بس هذه كانت.
yes, harder. Then if you have the 2008, you have
Oh shit.
you need to do duality here as well. So something over 1 plus omega 10 power. It's a similar.
Similar, yeah. We have done it.
So 8 and 10 are quite similar.
But we didn't do duality in this one.
الا
Now you need to do. No, you don't need to do duality in here. Yeah. Sometimes you need, sometimes you don't.
How?
هذه ما
This is
تحتاج
the one.
دواليتي.
How can I know that duality when I
Well,
need
it depends on it that in the
لو
formation on the
أعطاك
left
لهذا.
side or in the right side. The thing that you need.
Oh, hey, I got it. I went back to the previous.
Yes.
I will say it's
لما نجيب لك اللي يجيب لك اللي هناك تقوم تسوي دواليتي عشان تجيب اللي هنا.
So we've finished two topic now. So which is a Fourier transform and topic 4
sing.
noise.
Nice.
Next time we're gonna do sampling.
Sound
It's
very
the easy stuff.
Easiest one, sampling.
Yeah, you did it in communications.
Yeah.
And this one is a bit tricky here. It's a LTI system. And then we finish Pythagoras.
Now we finish the noise. Yeah.
Inshallah. 2 classes more or?
Yeah, 2 class more, we finish Pythagoras.
We finish what?
Pythagoras.
Douche.
Ah.
douche.
Should be at week 6, right? It's week 4. So
Yeah.
at week 6 we finish half of the subjects.
Inshallah.
On half.
Inshallah.
Thank you. Thank you. خلاص now we finished
Yeah.
for today. Okay, see you.